Hello, everyone. Thanks for coming to our talk. This is Dennis. I'm Benjamin. We're both working in Thalia's IT department, which is located in Münster. And as part of our development there, we're responsible for our e-commerce platform. And right now, we are trying to rebuild the whole thing. Let's say it this way. And we decided to reorganize to restructure our organization accordingly to the different applications that we want to build. So we're trying to give you an idea of what we're doing at Thalia and have a look at it from an organizational perspective as well as from a technical perspective. So, first of all, Thalia is a book-selling company. Now, most of our books we're selling in stores that look like this. Who has been to a Thalia store like this before? Okay, that's good. Most of you. And who has ever visited our online shop? Bought something there? Okay, good to know. So that we get an idea of what you already know about our company and at least have an idea what we are doing. Just go over some basic facts about Thalia as a company. We have about 280 stores that are located in the German-speaking area, Germany, Switzerland, and in Austria. About 4,000 people are working in the stores and the central departments like IT, human resources, and so on. In addition to books, we're selling a wide range of other goods as well. For example, music, software, home and living articles, electronic articles, hardware like e-readers, and so on. As part of our strategy, we don't just want to focus on the selling of these products in our stores, but we try to focus on our e-commerce business as well, and we try to build our services in a way so that we can provide these services to the customers via different channels. For example, the stores, our website, smartphone apps, and e-reader. To get a better idea of what the e-commerce platform is about and under which circumstances it is developed and was developed in the past, we want to have a closer look at some of the things that factor in on the development. Of course, we don't only have the stores in the three German-speaking countries. We have different web shops in these countries as well. I think at some point about 2 years ago we had, let's say, 10 to 15 web shops, and right now we're down to 6, but we're still working on minimizing different web shops. In the past, we had a lot of issues with different. Oh, I've forgotten this one. We've had a lot of issues with developing very heterogeneous functionalities for the different countries. Of course, we want to sell a lot of products and to widen our assortment from time to time. But nevertheless, different kind of goods bring different challenges, requirements, and complexities with it. The channels that I already mentioned before are mainly our stores, the classical website, different smartphone apps that we build ourselves, and apps that some third-party company is developing for us. So these are all the different things that we have to support. In addition, we have the Tolino e-reader, and on this e-reader we have a separate custom-built shop as well, where you can buy your e-books. On the technical side, for example, we have 2 ERP systems. Now it's very historical, grown over the years. We have a self-built one that we Yeah, we were working on getting rid of the self-built ERP system, and we have a second one, and this often leads to different requirements, and so classical if-else code that probably all of you know. And last but not least, let's get to the core of it, which is our let's say web shop ecosystem. The core of our e-commerce platform is still a classical web shop that's built in a monolithic manner. Think about 2 years ago, we had this web shop, and around the web shop, we had several back-end services built, and it was this classical distributed monolithic system where we could only release it once a month. So if you look back about 2 years ago, which issues did we have with our technical setup and with our organization? We could release our whole system once a month only, and one day we deployed the web shop and some services around it, and we had to do a lot of manual regression testing before. It was very time consuming. Of course, it's always frustrating to work with such things. The web shop is about 15 years old, and of course the code base has grown over the years. The development has started with an external consulting company that has developed it. In the first years, at some point, the development was insourced, and a lot of people have worked on it over the years, and at some point it just wasn't maintainable anymore. From an organizational standpoint, we were set up more let's say in a functional way, in which we had a lot of projects that we did. So every bigger feature that we were trying to get to the customer was set up in a project team, and people from the different, let's say, regular teams got to the project team, and you had this project team and the regular team, and they all were working on the same code base and the same applications. And this led to a lot of problems afterwards as well. So of course we said at some point it doesn't work anymore. We have to get faster to deliver our features to the customers more quickly. We have to become more flexible, and of course we want to be more innovative, which is very hard with a monolithic system. Of course that's pretty easy to understand, and it's something that of course we want to have, but at some point you have to think about how can we get there. And the approach was to rethink our technical setup and our organizational setup as well. Let's start with the technical things. From a technical standpoint, we decided that we want to have a brownfield approach. So the web shop that we had is still the thing that earns our money. So this is the web shop that the customers use, and we have to support it at least for some time longer. So we decided to build our new services, our new application beside the existing web shop landscape, and really to integrate it in the existing landscape that we already had. The second thing, which is or has become very popular as well, is self-contained systems. We decided that we want to have an architecture that is built around self-contained systems. Of course, the idea is that this system contains the functionalities of the three classical application layers: user interface, business layer, and persistence. There was no rule implied that we say, okay, one self-contained system has to be one application. It's more on the responsibility of the team how they want to build it. As part of the strategy, we would prefer to integrate the functionality of the self-contained system in, for example, in our apps, in our website, via classical HTML websites, or maybe some HTML snippets that can be integrated in an existing web page. But from time to time, this approach just doesn't work. For example, our e-reader shop has a lot of different requirements regarding screen size and the handling for the user. For example, you cannot really scroll down on an e-reader, and you have different e-readers with different hardware, different screen size, and so on. So at some points, we still have this approach that we have this like a shop application, or maybe a smartphone app that provides a user interface and some back-end functionality to call one of these services. So let's get to the organizational aspects. From an organizational standpoint, you have to think about that, or you have to think that the organization really has to fit what you want to do technically. If we want to build these self-contained systems, we want to have teams that are responsible for systems. Or let's say one team is responsible for one self-contained system. So we decided to build a product-based organization with different product teams. This product team, they should be responsible for creating products and deliver value to our customers. So how such a product team should be set up? Now we wanted to use an agile approach, so we decided that we want to have cross-functional teams that are self-organizing. Of course, at some point you have to think, okay, I get the ideas of it, but do I really know if they work? So we decided that we want to make a short proof of concept of the ideas that we had. So at some point, about 2 years ago, we took people from different teams and put them in a certain team for a proof of concept, and they came together to build one new feature in a new self-contained system. And after a couple of months, we came back together and had a look at what we've done and if all our expectations were met, and what we see as advantages from this approach. Okay, so what were the key takeaways from this time? We could develop and deliver features a lot faster. We were more flexible, and then how we could work and how, of course, how we can deploy. We saw that we can do these small deployments in production and don't have to do these big bangs with a lot of manual testing around it. To be able to really implement this continuous deployment approach, of course, we have to change the way and that we are testing our applications in a way that we have a more continuous quality assurance approach. In the past, it was mainly separate QA department, separate development department, or let's say at least teams, and you didn't collaborate in a really good manner. From a functional standpoint, we decided that we want to have one product owner that represents the functional side of represents the business requirements, and really a person who prioritizes all the different requirements and plans, for example, different sprints accordingly. One thing that we saw pretty fast, that we have to at least centralize a kind of pattern library asset management to be able to split up our user interface in a lot of different services that have to integrate together in one application, at least for the user.
Yeah, so far we saw lots of ideas and requirements we have to meet if we want to improve our company structure and the way we work together, as we just saw. And the question is, how are we going to get started right now? What do we have to do next to get to the situation we want to accomplish? So we started in 11/16 with a slide kickoff and invited all the new product teams, or so-called verticals, where we set the stage for this project. And in this kickoff, we stated some general conditions, just like, for example, we have to transfer responsibilities. So Benjamin just said we earlier had a functional-like structure, like quality assurance and developing and operations. And by restructuring our organization, we also had to, well, on the one hand, get all these people together in teams, and on the other hand, define somehow our new domains and domain borders. And accordingly, we also have to transfer knowledge into these new teams. And moreover, we also have to, of course, to fulfill these roles I just described, which are getting together in this new team. So we need someone who's used to security issues. We need knowledge in operations to build and deploy our applications, to operate with them in a productive environment, and yeah. Furthermore, the projects we just worked on, of course, didn't cease to exist. We couldn't just say, okay, there was a feature I just started to develop on, and now, due to the reorganization, I'm going to stop it. That's, of course, not working. Instead, there was the condition that the people who were already part of such projects had to keep working on them, or elsewise transfer the responsibility for the tasks they had to solve inside of this project to the new team. Last but not least, we also had to ensure that our self-contained applications, which also serve some kind of HTML, like we just saw, we have to ensure that our new features also work in the touch points. That's what we call them. So the e-reader, for example, or our app or our web shop. So our testing tasks don't end within our microservices or self-contained services, but they end within the functionality the customer consumes. And besides from these organizational-like aspects, we also have some technical conditions the teams had to meet. And that is, of course, as we just said already, they had to follow a self-contained architecture. And additionally to that, all these artifacts that are part of the self-containment process should pass all the stages that already existed. So like with development stage, integration stage, productive stage, and the components we want to deploy in a productive environment had to pass all these stages successfully in regard of testing. And they had also had to pass quality gates we defined. So like automated integration tests, automated UI tests, and what else is so part of the building process. Furthermore, we wanted our teams to make transparent when they deploy in a productive environment. So we wanted to ensure that a still centralized operation team, which keeps existing even after or meanwhile the project takes place, had to see that artifacts were deployed, so they can relate to component deployments if a problem in a productive environment occurs. On the other hand, the monolithic system also didn't cease to exist. So in some way, it has to be maintained. Maybe it has to be even improved if new feature requests require that. But we stated the fact that if so, it requires some kind of explicit permit to develop our monolithic system. So we wanted to enforce people to use the chance of rebuilding our technical and organizational structure, and to combine that with new requirements, so that our legacy system is not growing further when we actually want to replace it by something new. Yeah, and according to that, we also have still like monthly regression testing, which is of course necessary if we have still this monolithic system, which needs to be maintained. And if we integrate new applications inside of that monolithic system, we need to ensure that it's even still working. So that in the end leads to the situation that we have a couple of days in a sprint or in a monthly release. This monolithic system still analyze where we can't deploy our new applications on the integration stage, because the regression testing still requires a certain amount of manual tasks, which are not so easy to be automated. So in these conditions are in some way manifesting. What is manifesting a certain difference we also had to face in this restructuring project, which is why we're often talking about independent teams and cross-functionality. And what the important learning we had to make is that there's some difference between self-sufficiency and self-reliance, which actually means people cannot decide completely independently what they are working on. We still have a company strategy, some kind of a vision. We are prioritizing about many teams, across many teams, which tasks may be important or which features are maybe important. So they can't completely decide independently, of course, but they can. And that's what's meant with self-sufficiency in this context. They can decide what tools do they use, how do they prioritize on their level of business abstraction, and they can decide how do they want to work together inside the teams. Or do they, for example, want to use Scrum, or do they want to use Kanban, or don't they want to use any of this? That's up to them. Right, and just after the kickoff, we also had to inform, of course, the business units, because, well, in our case, that project had a high impact on the way we work together in our IT department. But of course, also the business units are part of this. Moreover, we established a first product owner meeting where our new product owners, which we didn't have before, should start to get used to this new way of working together. On a technical counterpart, we established some kind of weekly tech board meeting, is what we called. You can think of it like a meeting where architectural challenges or cross-team challenges are being discussed, and where solutions are found for in. Then we also had to had to point out what are the implications of the decision that we are using a self-contained architecture approach, which are well already mentioned in a way, and we are going to see what some kind of implications are going to come with this approach. Well, of course, we also had to mix the new people together, not only in a logical model, but also, of course, in a spatial reality. So we just also swapped working places and mixed them up accordingly to the new wished organization. And in the end, we of course had also to learn of some fundamental aspects in the question: how are we actually working in an agile way together, which we also did in January 2017. Well, after the preparation ended and the teams were set up so far, our management stated some further expectations the teams had to address. For example, we wanted them to establish recurring meetings like the planning meeting, sprint review meeting, estimation, refinement, and or whatsoever they need for their way of working together. Moreover, they had to develop some kind of product vision or idea of how they want to contribute and to get an understanding of what is their domain. Of course, we had a slight understanding of what the domains are per team, but we wanted to make it more concrete. And this should become bottom up from the teams. They should develop this understanding. And of course, with this also comes by the fact that they have to find the place in between the other product teams, other verticals. Moreover, they had to develop some kind of transition plan. By this we mean they had to get an understanding of how are they going to replace the monolithic system, which is just existing, and how do we want to replace this by our new self-contained systems. So how do we integrate? How do we deploy the artifacts? How are we isolating features from the monolithic system? And how we can what do we have to do to turn it off? As I just stated, meanwhile, we can't lose of what is required in a business perspective. So, what are our stakeholders in the new product teams? What are their needs, and how do we react to their needs, and how do we build the features that address these needs? Not being mentioned explicitly so far, which came clear to me when I created these slides, quite interesting for myself as well, are some questions that they weren't addressed. The teams were left with these questions without addressing these questions. So we had to ask ourselves, how do we actually build a self-contained system? Okay, we know it's somehow divided in 3 layers maybe, and they have to serve the complete stack. And okay, and then we didn't know so far. As well, we didn't know how do we actually integrate these self-contained systems in our monolithic system. Well, there's maybe some kind of web server which is serving the login page, for example. And how do we now bring our new login service, which is a self-contained one, into a productive environment? And how's he going to replace this login page actually without destroying its environment? We just mentioned we wish to follow a brownfield approach. How is that done actually? And last but not least, how do we in fact become cross-functional? What is to do? Do we have to share knowledge, or is it just being done by putting all these people together? And what is the impact of this on other teams? So many questions that left, and we want to address some of these questions in the further slides, so that you maybe get some kind of impression of what we did.
Just to give you a short idea of what technologies are that we are using. Of course, you can do it in a lot of different ways, and most of the things are something that the team can decide. They can decide how they want to implement it. I think most of our services, or probably all of them, are created around the Spring Boot ecosystem. I don't want to get in detail about really all of the different frameworks, but just to get you an idea how we build it. What might be interesting in the self-contained system aspect is that we replicate our data across the different systems via RabbitMQ. Not via Kafka, for example. What has been mentioned a lot of talks. RabbitMQ is was the choice there. So that's about the technical aspect. And most of the frameworks we have already used in the past. really the big challenge thing for us as the developers was that suddenly we are responsible for developing the user interface as well, and that's an area where we are still working on improving our knowledge and our competencies. So that's about the self-contained system topic, and now get to the question how we can actually integrate the new systems into the monolithic one.
Yeah, that's another question I've just pointed out. Maybe let's start with this example from our current web shop. It's maybe we can call it like product details page, where you can see next to the product image some specific characteristics of the product. You can see the price, the way to process the checkout, to put the article in the basket, and that's what this page contains, in fact. Now, if you want to transfer this approach on this concrete page, we could say on this left side of the page is some kind of the main content of the page. So what characterizes this page? What is the heart of the page? Is this primary content, the product details? Some kind of secondary content, which might be a step into another process, or might be maybe also some organizational interface on a business level, is something we can include here, but isn't part of the main content actually. So we have. And following this thinking, we have two kinds of contents. So as I just called, the primary content, which contains the main content of the page, and the primary content also can maybe include secondary content, like for example CSS or JavaScript you need to be compatible to your CI. The secondary content itself can be included, of course, on the other hand. And the only thing I know when I'm building secondary content is that I require a certain amount of page to be displayed correctly. And I would prefer to assume as little as possible in regard of what the primary content, which is including me, is serving. So this has actually two advantages if I assume a little. Firstly, I can be so reusability is ensured on the one hand, and on the other hand, the maintainability is also so because of loose coupling is ensured as well. But how is this being integrated now, actually? Let's get on a more technical level. You can imagine this product SCS as some kind of component which serves this product page and only the product page. But also, for example, provides some space for the header, for example, for the menu and some icons and the basket icon and so on. But actually this content comes from, let's call it, editorial content system. So this editorial content system is mainly serving this header snippet, so this secondary content, which can be included. And the same goes for the checkout system, which is providing a checkout snippet to just jump into the checkout process. And in the end, this page somehow needs to be served to the customer. And we're doing this by providing a web server, which is in the old world, redirecting to our old monolithic system. Let's say this is Thalia /product/article number 5. And now when we want to replace it by our new system, we can say, okay, all the calls that are incoming to this URL in the future are rewritten to our product SCS /product/5, or however you want to design your API. And in this way, we are trying to accomplish an incremental replacement of our legacy system. Next question is, how are we addressing several other brownfield aspects? So, for example, how do we deploy? How do we define fitting amounts of features we can deploy in a productive environment? How are we replacing old features, and how do we keep compatibility to our legacy system? That's the brownfield aspect, which is something we have to address here. One approach could be we are just cutting old twigs, which means we're dropping functionality we maybe don't need from a business perspective or from a technical perspective, and do inside the actual brownfield approach a little greenfield. So we set up a new STS and throw apart inefficient customer flows or inefficient technical processes, or simplify efficient customer processes. Maybe our concrete example, we had if you forgot your password, you need to log in. Then our old password page consisted of several fields you had to fill in to reset your password. And we just said, okay, why do we actually have to fill about 4 to 5 fields to reset our password? That doesn't sound necessary. And we threw apart all those unnecessary fields in this way, and reduced it to exactly 1 field to reset your password. And this is just a simple example of how you could use this chance to simplify your processes, maybe. And on the other hand, you could also question your technological fundament, which is what we did in this way in regard of what framework are we using. For example, we used plain Spring MVC and did a lot of configuration manually. And we used this project as a chance to switch to Spring Boot on every new application, which enabled us to throw apart many technical processes we built customly, even though there's actually standard solutions for. Another way, if you can't throw apart so many processes because often your business units might have the opinion that you can't throw apart anything because you need everything, then you could also think about do little big bangs. So you say, okay, I really need 5 fields for resetting my password. Then you could think of a process. You have to invent a process which enables you to survive the pre-productive stage. As I just pointed out, we are with a monolithic system, which requires regression testing and which requires a bit of awareness to be maintained accordingly, and you have to deal with this. And a way might be to create this process before pre-production or before production time. When you defined your MVP for the functionality you want to replace, then you can start to build and deploy it until your testing stage, and afterwards create some kind of migration strategy if you need it. For example, in regard of the password forgotten functionality, you again need to know the email address, for example, to be able, if you want to reset the password via email, you have to know the email address on your new application, which replaces the functionality. And for this, you of course need somehow a migration strategy. Yeah, and afterwards you just perform it and it's done. Of course, it's not that easy, but that's just one of the approaches we try to accomplish. We just followed. The last one we just tried to follow was the synchronization of the data. So, for example, if you have a case where you want to separate data sovereignty, but your legacy system also needs the sovereignty. For example, again, the email address. Many processes, ordering process, login process, for example, do both need the email address in some way, and the old processes don't cease to exist. So you have to think of how is when I separate this functionality from my old system, how is the data still being available in the old system. And an approach we tried out was the bidirectional synchronization of the data, where you of course need a process for, or need tools for. And afterwards, we performed dedicated integrity and performance tests, because we chose a way which is placed inside the applications. So we have an old application, new application, and both synchronizing in both directions every time when something is saved to the database. And we of course had to find out if it's still working properly, of course, in regard of performance aspects and integrity aspects. Last but not least, you again need a migration strategy for that. So it's just like it's just the same like in the last approach. So far regarding Brownfield, just to give you a short impression of what we did. For example, for our login process, we tried to cut some old twigs, and we used this bidirectional synchronization process. And for the payment process, we combined two other approaches. So in the end, you have to look in your concrete situation which one you want to follow, and some indicators that might lead to a result in regard of this question might be these. So, for example, as I just pointed out, if you want to separate data sovereignty, you might think about a synchronizational approach. If you want to reduce your amount of functionality you are putting into your minimum viable product, then you could think of using the cut all twigs approach I just stated so far, and that's how we came to a decision.
So let's talk about the cross-functionality aspect as well. When we came together as cross-functional team, so what experience did we have? What did we do to really establish ourselves in a cross-functional manner? First of all, we had agile mindset workshops. That's always a good first step to understand how this works and why do you actually do this. Secondly, it's always good to share knowledge, maybe in meetings or by documenting some stuff. I think two challenges that you actually have when you come together as cross-functional teams is that everyone is challenged to broaden his personal skills and to overtake responsibilities that he or she didn't had before. On the other hand, of course, this means that some people have to give up some of their responsibilities or share their responsibilities with other people as well. To give you an idea, what are the concrete areas that we had problems with, or that are the challenging ones? We have 3 examples, and the first one is IT operations. Before reorganization, we had one central IT operations team. They were providing the infrastructure, they were setting up machines, they were monitoring these machines. We had one central quality assurance team, they were doing a lot of monitoring, and suddenly every team is responsible for their applications and they have to do it themselves. Now our approach is that we still have this central operations team, and they are providing tools to automate certain things, tools that we as developers can pretty easily use. For example, they provide us an automated process that is built on Foreman and Puppet to set up virtual machines and to deploy. Second part is where you really have to think how you can set up your processes and your work as the business requirements topic. Suddenly you have one product owner in really as part of your team, and not only the product owner but the whole team is really forced to think about the business aspects of what you are actually doing. Everybody should be able to understand and not just think, okay, I'm doing this and that in a technical manner, but to really understand what the business needs. And some of the things that we that helped us a lot. For example, our public reviews to really provide transparency to our stakeholders, which we didn't have before. We were trying things like user story mapping to really collaborate with the team, with the stakeholders, all the different people together. We were trying things like behavior-driven development that especially us as a team helped to get a shared understanding of things. And the third topic is the quality assurance thing. Before we had a separate quality assurance team, and this whole QA thing was a really integral part of the development process. Now we as developers, we developed something, we deployed it somewhere, and the QA team then tested it, gave us feedback, but we didn't really collaborate. And now the quality assurance responsibilities are part of the team, and everyone in the team has to overtake some tasks, make manual tests from time to time, and write automated tests as well. I think that's something, a topic where behavior-driven development can help you as well, because you really set up your business requirements in a way that they already describe the things that you want to automate in your test, at least on a certain level. Of course, maybe not on the unit test layer. Okay, so now these are all the things that we have experienced so far and what we have done so far, and that's already nice. But now let's wrap up the things that we already said and think about the next challenges that maybe come up in the future.
Yeah, to sum just some aspects up. We just saw how we try to accomplish organizational and technical independence, and we hope just other companies obviously as well, that we achieve this by being more self-contained in organizational level and a technical level, and we try to achieve this by defining domain borders, which is not meant in an isolational manner, but more like so that it becomes clear who is responsible for what and where maybe technical interfaces. And on the other side, the sovereignty about the processes and data has to become clear by doing that. So we did it by providing full stack applications, by building some kind of cross-functional teams inside of a brownfield and partly a greenfield approach, and somehow had to integrate in our monolithic system, all together with people from different departments. Yeah, and that's what we are still doing currently. Thanks for your attention.
Okay, thank you very much, Dennis and Benjamin. Does anyone have questions? I think we have a couple of minutes left.
Thank you. One pragmatic question. Where did you get the product owners within 1 month?
Do you want to answer?
Yeah, that's a good point. We had the persons already in place. Before our reorganization, we had a separate demand management team. So they were doing a lot of the business requirements, tasks, and a lot of these people, the people from this team, overtook the product owner jobs.
Anyone else? Okay, thank you again. And yeah, that's it. Thank you.
Thank you.